Hello everyone and welcome to ManageEngine NetFlow Analysis webinar titled NetFlow, the de facto standard for traffic analytics. So thank you so much for joining, and today's webinar will include a highlight on the advantages of bandwidth monitoring and traffic analytics. And we'll then explain NetFlow, the technology widely used for bandwidth monitoring, traffic analytics, security monitoring, a lot of these stuff like this. And we expect the session to run for around 60 minutes, and during the session, your phone lines will remain muted. You can type in your questions during the webinar using the option available in your GoToWebinar window, and our expert panel will respond. We'll also have a question and answer session at the end of the webinar. So once again, welcome to the webinar, NetFlow, the de facto standard for traffic analytics. And before we start, very briefly on ManageEngine, for those who are quite new to ManageEngine. ManageEngine offers simple, easy-to-use IT management software that every business type can afford. ManageEngine products can technically cater to both small and medium businesses as well as large enterprises. We have products for network and applications monitoring to asset management and help desk. And there are also products for Active Directory, syslog analysis, vulnerability assessment, password management, and even integrated tools for complete IT monitoring and management. In short, almost anything that an organization needs for its IT department. So today's webinar or today's discussion would revolve around the need for bandwidth monitoring and traffic analytics. What is NetFlow? And then we'll go on to discuss what is flexible NetFlow. And then we'll see some of the devices that support flow export, NetFlow or whatever formats. And then we'll see use cases using NetFlow, how customers of ManageEngine NetFlow Analyzer actually put in NetFlow Analyzer or have used NetFlow Analyzer for some specific use cases, or how they used it for improving their network performance or solving certain issues. And then finally, we'll take on the widely asked or frequently asked question, is SLA good, or is it packets missing, or is it NetFlow which is good for your traffic analytics and your bandwidth monitoring? And finally, it will be, we'll take on the questions, question and answer session, where you can talk to us about whatever we discussed. You can ask your doubts about whatever you had, whatever questions you had during the webinar. All right, so one of the important requirements, the first and foremost requirement for traffic analytics these days is what is happening in your network. So profile your network. You need to know what is happening. You need to know who is using the bandwidth, who are the top talkers, what type of application or what sort of protocol, when is the application usage at its peak, what's your bandwidth or what your users are really doing, how bandwidth is being consumed, and how much of your bandwidth is being used by non-business applications. So profiling your network helps in future troubleshooting. You have reports, you know what is happening. So when something out of the ordinary happens, you have profiled your network. So now you know what is the normal usage. You know what is the usage pattern. So something out of the ordinary happens, you can immediately identify it. So this is the requirement for profiling your network, and this is actually future troubleshooting when as and when needed. And the next part is you can also, when you profile your network, when you analyze, when you keep a track on what is happening, you can also keep a record. You can see how your QoS policies are performing, because these days networks find it very important to have quality of service policies to manage the bandwidth, to police the bandwidth. So you can also find out what is the how is the performance of your QoS policies, and what protocols are being used. Because many networks, I mean, you might not be expecting to see any, let's say, ESP traffic or GRE traffic or something like that, some of these protocols in your network, or maybe even IPX protocols, something like this. And so you can look at the protocol distribution and see which protocols are being used the most, and then you can even, based on that, all right, you find that TCP or UDP or something else is being used. Based on that, you can design your QoS policies. Based on that, you can plan your network, your traffic, and maybe even design your ACLs to block some unwanted protocols, all these things. So quite a lot of reasons, profiling the network, finding out what is happening, keeping a track on your network data, your traffic passing through your network is quite important. And another important factor is troubleshooting. You need to have traffic analytics to troubleshoot your network quickly. So these days, like a link goes down, or your application is slow, your business application is slow, that is surely a big loss these days, because business application goes down. Maybe let's take a cloud-based application service provider. You can lose quite a lot if your application is down. And I even know a case like that. This guy, for this person, the service provider lost quite a lot of customers because of application downtime, which in turn was actually because of the internet link to the data center went down. So something like this, keeping a track on what happened, when it goes down, you need to be alerted. Stuff like the, for quicker troubleshooting, you need traffic analytics. And then something else is like if your website is slow, if you're an online business and your website is very slow, of course people are going to go after something else. They look for alternates. So that is another reason why you need traffic analytics, to find the root cause of internet and application slowness. Find out what caused the bottleneck on your lead line, what sort of application is suddenly going high, or if you're using real-time voice and video for your customer communications. If there is choppy video or maybe there is a lot of jitter in your voice communication or your video communication tool, then you definitely need to know what sort of application on the link is causing this. Maybe it's not video, maybe something else is running on your network that is using the bandwidth. So for quicker troubleshooting, you need you need bandwidth analytics as well as traffic analytics. So we could go on with scenarios which can actually explain why this traffic analytics is quite important for your troubleshooting purposes. And so in short, traffic analytics, I would say, is necessary to identify illegal application usage, prioritize business applications, or find out bandwidth heavy applications like voice and video traffic usage, and quickly troubleshoot issues and alleviate your network issues, which in turn finally improves your service and leads to more uptime. And the networks today are bigger, they're faster, and they're much more complex. So telecommuting is the most important factor. Like I think most of your networks, most of your enterprises these days have actually started supporting telecommuting, that is work from home. Even my office, at least 50 to 60% of the employees are actually telecommuting. So telecommuting is you have your employees working out of your office, working from home, and maybe they take your laptop out to a coffee shop or something like that and connect. And yeah, that laptop is not protected. After using the laptop out there, they might get infected by a malware or virus or something like that, and they walk straight into your network, connect to your network, and virus starts spreading within your network. This actually happened long back in my office. So one of the guys, we didn't pinpoint who it was at that point of time, but yeah, he used his laptop outside, and then he came back, connected his laptop, and over the next 1 or 2 weeks, we had lots of problems. All the computers in the network were actually affected, after which our network admin team had to analyze from where this is happening, and we had to reinstall almost all the operating systems in the network. So that is one problem with telecommuting. There's no more network perimeter. The network perimeter is not your edge router or your firewall as it was. It can be anywhere. It can be the customer's, it can be your salesperson's home. It can be your salesperson working from some coffee shop, or your marketing guy out on a tour or something like that. So networks, there are no more, it's much more bigger. And then the technology is also getting faster. You had 1G network and then 10G, and now even 40G has just come in, 40 gigabit networks have come in, and suddenly you find all these people announcing about 100 gig. 100 gig is the standard. Even recently, like last week, Cisco said, they'll support 100 gig up to, I guess that was around 3,000 miles or something like that. So 100 gig is the in thing now. You have more bandwidth. You need more bandwidth because more number of users are getting into your network. You are expanding. Almost every enterprise is expanding. So you have more users, more number of applications. Maybe you've decided, oh, all right, let me go for a cloud-based service instead of hosting it in my data center or in my own office. Now that's cloud, shifting to cloud. That's more data on your network, on your internet links. So 100G might be necessary for you. So whatever, you have more data. When you have 100G networks, you definitely are going to have more data. After all, you wouldn't have shifted or you wouldn't have adopted a 100 gigabit link just for the sake of being technologically advanced. You definitely would have had the requirement. So that is one more reason. And then, like the old time, we don't have the hub and star topology. Most of the networks, MPLS links, all these stuff have come in, and there is complex mesh topology. All these one link goes down, the redundant one comes out, load balancing, and all these things. So networks are bigger, faster, and complex, which means we cannot keep a track on everything that's happening by monitoring a single router or a single switch. You need constant updates on everything that is happening without any strain on your network usage. If there is, understand how your network has been going on. Find out if there is any sudden change in traffic pattern. So if it was one router, one firewall, one switch, and just one network in there, you can easily found out, all I find there's something, there's HTTP has suddenly increased over 60%. That's not usual, so we have checked it out. But now, expanding networks, more number of branches, all these stuff, increased link capacity, people working from home, VPN, 3G, all these factors actually lead to making monitoring quite difficult, or keeping a track of things quite difficult. So which is why you need traffic analytics. You need to monitor your bandwidth, find out what is happening. You would have profiled your network earlier, and so if something out of the ordinary happens, you can immediately find it. So that's another reason for traffic analytics. And the other trend these days, important factor, very important I would say, is network security. Because lots of enterprises we see with the YOD trend, bring your own devices. And again, the telecommuting factor, which we talked about. So what happens is you have your own users carrying threats physically into the network. Now, it's not necessary they're doing it for someone else by mistake without being aware of that their laptop or their iPad or their 3G phone has been infected. They're carrying the devices straight into your network. So remember, all of you might remember what happened with Sony or Lockheed Martin or many of those enterprises who were attacked or hacked in 2011. So I'm sure, or you would all be definitely sure, they would have had an IDS system, intrusion detection system, or an intrusion prevention system in place. But they were still hacked, they were still under attack, and data was stolen, and stuff like these happened. So what happened? Zero-day malware, that would be the end. Zero-day malware goes undetected by your IDS and IPS systems, and access control lists on your firewall, they're mostly designed to block, you would have designed it mostly for the HTTP traffic or how to control it, and or lots of those familiar traffic, and almost every network allows HTTP. So zero-day malware is something whose signature is not available on your IDS and IPS. And IDS and IPS depends upon signature to find out if the traffic coming in is a malware or a virus or something like that. So network security, keeping a track on your traffic, identifying what sort of application is coming in, tracking out something new that happens, something out of the ordinary. For all this you need traffic analysis. And then there's also a factor like not only the threats coming from outside into your network. Maybe you could be hosting a spam bot or a denial of service botnet. What happened is, I read about a case where one of the users, they received quite a huge bill from their ISP for bandwidth upload. Now, as well as the administrator knew, he hadn't made any change in his network. He hadn't modified his network. He hadn't added any new applications. So what happened? He gets a huge bill. He goes for a traffic analysis and finds out actually his computers, computers in his network had actually been infected, and they had been taking part in different DOS attacks, which means all these computers who are a part of that botnet, they would actually send out traffic to the destination, to the target, and this is why we were seeing quite a lot of traffic, outbound traffic. And another case is related to the spamming. This person actually got a warning from her ISP stating that she's sending out too many spam emails, and the IP address was the firewall's IP address. So again, they needed traffic analysis. They digged in and found out that actually some of the computers were infected by a malware and were sending out spam emails automatically. So considering all these factors, bandwidth monitoring and traffic analysis is important, especially with network security. Now, capacity planning and cost savings, that is something that goes hand in hand. Taking a capacity planning decision and along with that inputting cost input is high. So whenever bandwidth issues come and the immediate reaction is actually for adding a WAN optimization solution or a bandwidth upgrade or purchasing something like deploying something like Cisco WAS or Riverbed, stuff like these. So before you do that, wait and check your usage. We have seen a lot of social media traffic usage these days, Facebook and lots of applications on Facebook which claims that they've got around 1 million active users. Now, if they all start accessing, if at least 30% of those users start accessing the applications or social media from your office, a huge percentage of your bandwidth is actually going to take a hit. So find out how much of your application, how much of your link is being used by social media traffic or unwanted application or non-business applications, and then find out who is causing the condition, which application is using up the bandwidth and causing a spike in your network, and then use your QoS policies. Take decisions with reports to validate your validate why you chose for a bandwidth upgrade or why you decided, all right, a bandwidth upgrade is not necessary at this point. What I need is more control on my traffic, more policing on my traffic. So informed decisions actually save money instead of going in for a direct bandwidth upgrade or something like a WAN optimization solution. Now, next part is SLA verification and usage-based billing. Most of your enterprises, when you take a connection with your ISP, you would have had an SLA for a committed information rate or a committed data rate. So your ISP says, all right, fine, I'll promise you so much of bandwidth, that is the committed data rate. Your data is always going to go at the speed. So, and even when you say everything is slow or something is slow, your service provider will still say, all right, everything is fine. But are you sure is it really being met? Is your SLA being met? So what do? You need to verify your CDR. You need to know if your data rate is being met, and for this, it's best to have your own reports in hand. So that is another reason why you need traffic analysis. And then there is this concept of billing. So there are these enterprises who do department-wise chargeback. So when you want to opt for an expensive billing solution to find out how much of what is the cost incurred. So what you can do is monitor the bandwidth usage, find out which application is using it, which IP address is using it, and with that, instead of an expensive billing solution, you can actually create your own billing reports. So most of the bills, everywhere, the bill is generated based on speed or volume-based usage, and you can get both this information by from the traffic analysis or rather from bandwidth monitoring. So that is one way, department-wise chargeback, and some of you can even use this for your verifying if the bill that was given to you by your ISP is proper, because with ISP, I'm sure you people pay a lot of money. So if the bill is suddenly out of the ordinary, all right, verify, use your own billing reports, verify if that's correct. And that is another requirement why you should use traffic analysis. All of these help actually create, whatever we decided, whatever we talked about, all this helps you create a high performance network. So what is important is profiling the applications, ensuring that optimal bandwidth usage, studying the effect of changes. I mean, you made a new change in your network, maybe added a new application or implemented a new policy in your network. You need to know what has happened, how has that change affected your network bandwidth. So for stuff like this also you need monitoring and analysis. Maybe it's a pure policy change, maybe a new policy or something like that. Or maybe you have introduced a new technology, IPv6. So many organizations are now adopting IPv6 or maybe going for MPLS, maybe increasing the speed like 40 gigabit or 100 gigabit, and maybe then even voice or video traffic, stuff like these. So whenever you implement a new technology, how do you find out what has happened, or how do you find out the impact of the new technology on this on your network? Or how do you actually find out if the new technology you adopted is working properly? How is its performance? For this factor also you need bandwidth analysis. So these are some of the reasons why we needed bandwidth analysis. And before we go into NetFlow, NetFlow is a technology. That was a technology developed by Cisco initially as a switching part, and now has become the primary IP traffic accounting technology in almost every enterprise. So, like NetFlow gives you answers about who is using the traffic, or what was the traffic, what sort of application was being used, when this happened, and who is the source, or where is the destination, all this. So it answers the who, what, when, and where of your network traffic. And almost all major vendors in the market, like NetFlow, all major vendors support NetFlow or some other flow formats. Like NetFlow, you have it from Cisco, Actran, and 3Com. And then there is Flow from some of the other vendors like Alcatel, HP, Brocade, Entraces, Dell, so many other vendors in the market. And then you will have IP6 from Nortel, and JFlow was from Juniper. So then there was NetStream, and lots of these companies are adopting NetFlow or some of these other technologies. So none of the enterprises are actually being left behind. You have a flow format, one flow format or the other for your bandwidth monitoring or traffic analysis. Now before we go into details on NetFlow, let's have a poll to see how many of you have adopted NetFlow, or rather for what reason have you adopted NetFlow in your network. So you should have the poll on your screen now. So you can see the questions on your screen. What was the single most important reason for originally implementing traffic analytics in your network? So you should be able to see this question on your screen, and you can choose whatever the answer was. So the poll is open, and select it. You should have a form where you can see the poll. You can select what is the most appropriate reason why you had actually or originally implemented NetFlow analytics or traffic analysis in your network. So we'll keep the poll open, and we have lots of people answering the questions. We'll just keep it open for another 30 seconds or so. And so those who want to answer the questions, those who want to take part in the poll, have a look at your screen and choose the answer. Right, just wait for another 10 seconds. All right, so let's see the poll results. You have it on your screen now. So, all right. So, Facto troubleshooting, and the results should be on your screen. Yeah, the Facto troubleshooting, network profiling, and security network security. These are the reasons why we find, but the largest number of users was being for faster troubleshooting. That's good. But then I see that not many have, or rather nobody has selected usage-based billing. Now that is one more factor which so many of you can actually consider for your network actually, because you already have a technology in place. Usage-based billing would be a good idea to have your verify your ISP bills or verify your SLAs. And then capacity planning is also very low usage, but that's also a very good usage of bandwidth monitoring and traffic analysis, taking capacity planning decisions. And traffic profiling, I'll say, traffic profiling and troubleshooting are important factors. This was because quicker troubleshooting means more uptime. Profiling means identifying issues quite quickly when something happens. And security is also some factor some of you should consider, because security, it's not always that IDS or IPS, intrusion detection systems or IPS, can actually save your network. So anyway, let's go back into the presentation now and see what is NetFlow. So like I said, NetFlow is a traffic accounting technology that was introduced by Cisco, and now it's the primary traffic accounting in the world. So what is a flow? Flow actually, a flow would consist of 7 unique fields. That is what defines a flow. A flow consists of source interface, protocol, source IP address, destination IP address, source port and destination port, and type of service. So these 7 fields is what is defined as a flow. Now we'll see how this comes into the picture. How NetFlow works is you have traffic passing through your routing and switching devices. So whenever there is traffic passing through these interfaces, the flow is created. That is, the header information of your packet is analyzed. A flow is created. That is, remember the 7 fields which we talked about. So a flow is created based on that and is stored into a NetFlow cache. Now remember, it is not the whole payload of your packet that is captured. It is just the header information, or rather just the fields which we discussed, that is captured and stored into the NetFlow cache. And these flows get grouped and exported in UDP packets to a collector based on the active and inactive flow timeout. And we'll go deeper into active and inactive flow timeout in a few slides. So as you can see on the screen, the router through which traffic is passing based on the 7 key fields. A flow is created and stored into a cache, and then it's exported as UDP packets to your flow analyzer. So this is how basically the architecture of any NetFlow implementation is. You have your network, and most people prefer it on their edge router, their ISP router, so that they can see how much of their RAM is being utilized. So NetFlow is enabled on interface, and NetFlow packets, that is, the flows are sent as NetFlow packets in UDP format, UDP packets to your NetFlow collector. So each NetFlow packet is somewhere around 1,500 bytes, and it contains around 20 to 50 flow records. That is 20 to 50 flows. And typically what I have seen during most of my analysis for NetFlow is like it would be mostly around 30 or 32 packets, 32 flows in one NetFlow packet. So the packets are then stored, and your information, your bandwidth information or traffic analysis information is presented by the NetFlow collector. So this is how NetFlow works. So let's go in detail into what is NetFlow. The NetFlow technology. Now, when I say NetFlow, this also means Sflow or IPFix or JFlow. But since NetFlow is the most widely used technology, I would actually say NetFlow all the time. All right, so NetFlow answers the questions on who, what, when, where. It tells you how much of packets is being utilized and all. So who is like source IP address and destination IP address? What was the source? What was the original source from which the NetFlow packet is coming, and what is the destination to your network? So maybe when you're looking at your internet link, when you're looking at traffic going out of your network, then you see the source IP address as your LAN. So from your LAN to what website or what IP address is all this traffic going to? Is it actually your business application or going to a data center, or is it something else? Maybe someone wanted traffic, HTTP, unwanted HTTP traffic, or BitTorrent or peer-to-peer application, something like this. And then you know what source port and destination port and the layer 4 protocol. So a combination of port and protocol is what defines an application. Like HTTP is HTTP, or you get Telnet or FTP, 21 TCP, 23 TCP, all these. So a combination of source and a port and protocol defines an application, and so NetFlow can actually give you information about the source and destination port as well as the protocol information. So it answers what was the traffic, and then there is when. So the flow start time and end time. When did the conversation start? When did the conversation end? And so it gives you information about when this happened and how much of your bandwidth was being utilized by this conversation. What was the packet count? What was the object count? That is the volume. So what was the usage? And then there is the quality of service value. You get type of service, TCP flag, protocol being used, your differentiated services, DSCP code point, so your QoS related information. And then there is the path, that is the input and output interface of through which the traffic came. I mean, the interface through which the traffic came into your network, the interface through which the traffic went out of your network. You know the path through which the traffic happened, and then there is the route, that is the next hop information. The source is autonomous system information, or the destination autonomous system information. So route information is also there. The NetFlow gives you quite a lot of information, valuable information, which you can actually find out, through which you can actually find out everything that is happening in your network. So these are the various versions of Cisco NetFlow. NetFlow version 1 was the original implementation. It's now obsolete and nobody's using it, and I'm not even sure if there are any flow collectors which actually support version 1. So only IPv4 traffic information is available from it. And then there is NetFlow version 5. That's the most widely used version. Supports autonomous system reports and a few additional features like next hop and TOS fields and stuff like that. And then there was version 7, which was specific to Cisco catalyst switches, the 40, 500, 6000, 6500 series catalyst switches. We supported only NetFlow version 7. So later on, there was also NetFlow version 8. It is exactly the same as version 5, but they had support for around 11 different types of flow aggregations. So flow aggregation is further grouping of flows before they are being exported. Maybe all the flows are grouped based on their source IP addresses and exported with no other information, or all the flows are exported based on their destination IP address or type of application, something like this. And version 9, that is the latest version. It's also called as the flexible NetFlow. So it's customizable. Flexible NetFlow is customizable, template-based, and supports new data fields. You can export not just the traditional information that was available with version 5, but new information like MPLS headers, MPLS labels, IPv6 traffic, NBAR information, QoS information, specific information about your live rich media traffic, all of these. So these are the different NetFlow versions. Now let me a bit more on NetFlow, like what are the commands used on NetFlow version 5. So IP flow export version and the version number specify what sort of version has to be exported, which we saw earlier, version 5 or 7 or 9. But most people now prefer version 9 because of its flexible format of export. And in addition to that, you can also include origin autonomous system or peering AS. So origin AS shows you what was the original AS autonomous system that was sending the traffic and the final endpoint AS. Whereas peering AS shows you the immediate peering origin, that is the immediate peer AS numbers, that is the source as well as the destination. So that sort of AS info is available. And IP flow export destination, that's exactly what it says. flow export destination, you should give up given your IP address of the flow collector and the port number is listening on, and then there is the IP flow export source interface. So here you need to choose an interface which is easiest to reach from your exporting router to the collector. So which has the best route to the collector. So maybe it can be a loopback interface, or maybe it can be a LAN interface, but any interface which can easily send traffic to your collectors. And this is the commands which we just talked about earlier, the active timeout and inactive timeout, based on which flows are actually exported from your cache, from the NetFlow cache to the flow collector. So inactive timeout actually specifies the time period for which an expired flow remains in the cache. So what does it mean? Now you have a conversation starting at let's say 10 a.m. and it ends at 10:05. So once it ends at 10:05, for the next 15 seconds, there are no packets added to that same conversation. So the flow is now inactive. So in such a scenario, when no packets are received for 15 seconds, the flow is considered as complete, and information about the conversation is actually exported to your flow collector. So that is what an inactive flow timeout specifies. The default value is also 15 seconds, and most of the flow collectors also specify 15 seconds for the flow export. So every 15 seconds, a conversation that is complete, information about a conversation that is complete is sent out. Or rather, not every 15 seconds, within 15 seconds of a conversation getting completed. And the other one is the active timeout. Now, what happens is, like I said earlier, 10 o'clock a conversation starts, it goes on till 10:05. So the conversation is still active. Now, in such a conversation, let's say what happens at 10:01, the conversation is still active, the flows are still being received, packets are still being added, information is still being added to the flows inside the NetFlow cache. So it waits for 1 minute, all right, the flows are still active, packets are still coming through, and then it exports information about that active flow. And same way, 10:02, all right, the flow is still active, and it exports information about that flow at the end of that 1 minute. So every 1 minute, or at the end of 1 minute, if the flow is still active, information is exported about that conversation. So active flows are exported every 1 minute, and inactive flows or inactive conversations, it is exported within 15 seconds of it being completed, which means the lowest granularity a reporting tool can go for is 1 minute. So active timeout, the default value is 30 minutes, but always go with 1 minute to see the most accurate reports, most accurate, real-time reports. So that is what the active and inactive flow timeout is. So let's go a little bit more detailed into flexible NetFlow. So NetFlow version 9, that's what the flexible NetFlow is based on. That's a highly flexible flow export option. You can customize it according to what you need. You can select what are the fields. You saw those 7 fields, right? You can actually select, all right, fine, I will select all only on these fields. So you have a user-defined key and non-key field. So that's one of the advantages of flexible NetFlow export. And then you can monitor a wide range of IP packet information, which NetFlow version 5 did not have. So what is that? So that is MPLS labels, IPv6 traffic, NDOT protocols. You can get live performance of media flows, multicast IP traffic, VLAN IDs, and even layer 2 protocols, MAC addresses, layer 2 interfaces and MAC addresses. All these things, you can get all this information from your flexible NetFlow, which NetFlow version 5 could not actually do. So you implement IPv6, you implement a new technology in a network like IPv6 or VoIP or WebEx. So telepresence or voice and video solution, some other voice and video solution. So you can do specific monitoring of these technologies using flexible NetFlow, which actually lets you customize your flow export options. So let's look at the structure of flexible NetFlow. What includes, or what are the components that are included in flexible NetFlow? One is the flow exporter. Flow exporter includes, or flow exporter is where you specify what is the destination to which the flows have to be sent, and what is the source interface through which the flows are exported, maybe loopback or fast Ethernet. And then you can specify the listener port of your NetFlow collector. For ManageEngine, NetFlow Analyzer actually uses port number 9996, UDP 9996 actually for listening to flow, so you can specify that here. And then you specify the export protocol, that is which version of NetFlow has to be used. That is export protocol, NetFlow V9, or you can use V5. So for now, they're just given V5 support for, let's call it backward compatibility. And output features is one of the other option in flexible NetFlow export. This is used for exporting NetFlow packets over a crypto master node. So only if we apply this feature would NetFlow packets get exported over a crypto master node, because earlier with NetFlow V5, it was not exported. NetFlow packets could not be exported over crypto master node. That was the Cisco bug. So from flow exporter or from output features, let's see what is next on the screen. Then comes flow record. So flow record is where you define your fields. Earlier we saw the 7 fields that were there in NetFlow V5. So you can now you're seeing there are 2 types of flow records actually. Predefined flow records is what you're seeing now. So that has 2 options. I mean out of many, some of the frequently used one is NetFlow original, which actually is this NetFlow version 5 fields as it is, and NetFlow IPv4 original input. Just to be more specific, that all right, IPv4 traffic information has to be exported with additionally the AS info. So that is predefined flow record. So this way, if you have to adopt flexible NetFlow, but you do not want to use your own key records, I mean define your own fields, key fields and non-key fields, then you can use one of these predefined flow records. Let's see what next comes up on the screen. That is user-defined flow records. So user-defined flow records is what helps you customize your flow format. So you can use match statements like match IPv4 address, match destination address, source address, and all these things, and specify what are the key fields based on which a flow is created. And in addition to that, you can use collect statements. So some of the collect statements are, you can see that on screen, like additional information that has to be collected using NetFlow. So after your flow record, you have created your flow exporter and your flow record. So what's the next set of information you need? That would be a flow monitor. So what is a flow monitor? You associate a flow exporter and a record to a flow monitor. And the commands used for this is you type in your exporter name, and then you associate, all right, when you create your flow monitor name, and then you define, all right, exporter, and whatever name you create for your exporter, and then your record name. So if you use the predefined record, you don't actually have to create one. You just have to, you can come straight from flow exporter straight into flow monitor and type in the record NetFlow original. Or if you created a record for your own purpose, for your own monitoring purpose, you can just type in that name. And then you need to associate that flow monitor to an interface. And that is using the command IP flow monitor and monitor name, and input defines that, all right, ingress traffic has to be monitored, and egress defines that exit traffic has to be monitored. So once that is done, your flow record is complete, and this is sample configuration. What you see on the screen is an example for a user-defined flow record, because you define the name, you define what all the information has to be collected, what are the match statements to be used, what are the collect statements to be used, and whatever fields you want, if you require, they can be added. Now, something like match IPv6 can be used to collect IPv6 traffic information, MPLS labels, multicast traffic, and video traffic. All this you have your own flow records that is easily available in Cisco's records or Cisco's documents. And after your flow record, you need to create your exporter, which is where we saw that you specify the destination IP address, the port number of your ManageEngine NetFlow analyzer, the listener port of your ManageEngine NetFlow analyzer, and specify the export protocol. And then you are associating with your flow monitor. And here, earlier you saw the active and inactive commands of NetFlow version 5. Here, this is the relevant commands used for NetFlow v9. So you specify the active timeout and inactive timeout. And from there, you associate that flow monitor or to an interface. Now most people who actually use NetFlow or are planning to implement NetFlow, one question which is asked is, what is the performance impact of NetFlow on the network, on the devices, on your routers or switches? So as far as NetFlow is concerned, for 10,000 active flows, the additional CPUs, as you can see there, it's just somewhere around 7% of additional CPU, and for 65,000 flows, it's 23% of extra CPU utilization. Now 10,000 active flows, that is something that I've seen only in very high traffic environments like an ISP or a managed service provider or hosted service providers, only data centers. Only these kind of cases I have seen 10,000 or more than 10,000 active flows per second. But typical networks, large enterprises, including large enterprises who are monitoring their own network, the flow rate will stay somewhere around 6,000 to 8,000 flows per second, and you can expect it to be average around 4,000 flows per second actually. So 10,000 flows per second is just 7% additional CPU. So you can see that, all right, even the highest flow rate does not cost much of a CPU. And somewhere more than 15,000 flows per second is usually seen very specifically in service provider environment, internet service provider environment, and that will not the smaller ISP, but the huge ones like Verizon or AT&T. Those kind of networks is where you come across 65,000 flows, active flows per second. And bandwidth usage, though there are no specific estimates, there are no solid calculations done here. Cisco says you can expect around 2 to 3% of additional bandwidth load on the link that is exporting NetFlow data. That is the IP flow export source interface. On that link, you can expect around 2 to 3% of additional bandwidth load because of NetFlow export from that particular device. So that is the bandwidth usage. But I would say more than these statistics, I would say ManageEngine or NetFlow analyzer, we have around 5,000 or 6,000 active customers actually. And I've never come across a case where NetFlow usage or using NetFlow or enabling NetFlow has actually affected the bandwidth or brought down the network or caused a spike in the network utilization. So that is the performance impact of NetFlow. Very minimal, or I would say next to nothing. So let's look at some of the flow exporting devices, supported devices from Cisco. So as far as Cisco is concerned, almost every device from its basic 800 series router to the advanced 7200 or 7600 series router, 12,000 series, ASR, all these routers actually support NetFlow export. And when it comes to switches, I'll say from the new iOS frames or iOS releases onward, except for the Cisco Catalyst 2960, the 2900 series, everything else supports NetFlow export. So those who already have a Cisco Catalyst device, then it's only, you would find that only the 4000 or 4500, 6500 and 6000 series, only these actually export NetFlow catalyst, only these catalyst switch. But now, over the last 1 or 2 years, they've started NetFlow support on every catalyst switches. Then the Cisco Nexus, the data center switch, and even the Cisco ASA firewall. All these can export NetFlow. But looking at the other vendors, Xflow from xflow.org, that is an open source option, and everybody else that Cisco would have implemented SLA, Alcatel, Rocket, Foundry, Dell, Entraxis, Extreme, Poston, or what you see those on the screen, long list of names. So all of them and much more than that actually have implemented SLA. And Juniper devices are seeing request range. They have JFlow, and then they have SLA. They even support something called as IP6, which you can see next. That is going to be developed as the standard for flow export. Right now, it's described in RFC 3917. You can actually read it to get some sleep. So RFC 3917 defines IP6, which is going to be the standard for flow export very soon. So that is based on NetFlow V9, provides flexible options, addition of custom, vendor-defined fields, or more fields that were than that was or that is available in SFlow and NetFlow version 5. And AppFlow is actually an extension to IP6, which is specifically for applications monitoring. So what happens is application-specific data is captured from a network, and you need an appliance for that. And right now, only Citrix NetScaler is capable of that. So Citrix NetScaler captures the app-specific network data and generates AppFlow records, which can be then exported to your flow analyzer software to generate your application-specific reports like round trip time, jitter, and latency for the application. And there is NetStream from Huawei and 3Com devices. So every vendor, you would have seen that almost every enterprise level network vendor or device vendor has a flow export option or the other. So anybody who has a network, even non-Cisco devices or Cisco devices, anybody who has a network with enterprise level devices can actually do bandwidth monitoring and traffic analysis by using one of these technologies. And another big advantage is you don't have to go for a different license. You don't have to buy a new license. This is not hard to set up. These are very simple set of commands which you've just seen. So simple set of commands, you just need to enable them. Your flows are automatically exported to the flow analyzer. And as far as flow analyzers are concerned, ManageEngine requires no configuration. You install it, it captures the packets and starts showing you reports in like 1 or 2 minutes. So that's what flow and so that's how easy it is to set up or implement NetFlow in your network. And earlier we saw the impact of NetFlow on your resources is also very minimal. So let's look at some of the use cases. One is profiling your network, like finding out which of your links is most utilized or underutilized, who are the top talkers and which are the top applications. And understanding application usage, finding out when a certain application is used the most and what speed does it go through your link to your data center or your server farm. And all this can help you with your implementing your QoS policies, your routing, or deciding your AS. Okay, maybe you find that one of the links is not utilized much. Maybe you can route your traffic through those links. Or you find that one of the peering AS has very less traffic. Why don't I go through that instead of going through a link where I have to pay much more, something like that. So profiling a network gives you a very good idea about what is happening, and based on that you can take your decisions. And finally, profiling the network helps you in quicker troubleshooting at a later point of time. And this is one of the use cases which happened to one of our customers. So what happens is application was slow and they had to do, that is when they decided to implement NetFlow. So what they did is they installed NetFlow, started monitoring their links, and found out which link has the highest bandwidth usage. So once they found out the link bandwidth usage, as you see on the screen, they found out the highest utilized link, drilled down on it, and found out which application is being used. So what happened is in their case, they found out that HTTP was being utilized much more than the CRM application or the business application. And now they needed to find out, all right, HTTP is being used, but what is the reason? That was because of incorrect priority. So earlier, CRM or the business application had a higher priority than HTTP traffic, but somehow all that changed, and what happened is the business app also ended up with the default priority. So now what happens is it has to fight with HTTP traffic, so it is best effort. When you're a default, it's best effort for your application, so they have to fight with one another to go through the link to get the bandwidth. So this is why HTTP, obviously, because most of the applications, most of the traffic is going to be HTTP. It got, it got through, and the link was much more utilized by HTTP, and your business app ended up being slow. So they use NetFlow reports and ManageEngine NetFlow analyzer to find out what is happening. Quick drill down, that is the major advantage. You can find out your issue in the least possible number of clicks. That is what we kept in mind when we designed this. And something else is your new age networks, which we talked about, bigger, faster, and complex. So NetFlow use case is that you can implement or deploy NetFlow in any type of network, whether it's 100 gigabit or 10 gigabit or 1 gigabit, or even if it's a big network with hundreds of devices or thousands of network devices, or even very vast networks where you cannot go ahead and implement IDS or IPS solution or a packet analysis solution. You can implement NetFlow anywhere with no strain on the network and not much of storage resources needed. So that is where NetFlow is important. You can use it in any sort of high-speed networks. And security is the new use case again. So what happens is IDS and IPS, most of these IDS and IPS are actually dependent upon signatures for capturing network anomalies. Now, there are intrusion prevention systems actually which are based on, which are not based on signature but based on network behavior, but they are quite expensive. So what you need to do is, that is where NetFlow is important. So using NetFlow, you can detect or capture non-signature based anomalies, which means you're capturing zero-day malware, which could have possibly come beyond your IDS or IPS system. And within that, or even you can capture those flows or those anomalies which originate from your LAN network and go out into the internet. So that is one important scenario where NetFlow can help you, network security. So you find out what sort of attack is happening, what sort of issue, network problem or network anomaly is happening, and then you can drill down on that and see what is the problem. You can see the target, the offender, how it was routed, all this information. So generally, not all the flow analyzing software or network monitoring software can actually give you the security analytics information, because you need to further drill down, you need to further analyze our network traffic usage. So ManageEngine has this option where you can use NetFlow data for this security analytics information. And then there is capacity planning, which we saw in the beginning. What's the bandwidth upgrade which you plan? Was it really necessary, or is WAN optimization needed? And so you can analyze application usage. You can find out or block the bandwidth on the application using your quality of service or access list, and then check the link utilization. After you find out the link utilization, then decide, all right, we need more bandwidth, or like to block these applications. And so finally, informed decisions with reports to validate that actually leads to higher cost savings. So these are some of the screenshots from how a capacity planning decision can be made using NetFlow report. You get reports on what has happened, every bit of information on traffic usage pattern, and how much of application growth has been there over time, which helps you decide, all right, fine, the length is sufficient, I don't have to do anything else. So then the SLA verification and billing. So using the reports, you actually can verify the committed data rate from your ISP, generate your bills and compare it with your ISP, and for department and project level billing, account per network, and you can charge your projects for that. So you can actually create a bill plan, define the speed or volume based on speed or volume, and you can get your billing reports based on what how much of the usage it was. So Something else is analyzing application usage and how your voice is performing. And so you can find that over time, maybe if voice calls are getting choppy, then you can check it out. And this is another case one of our customers had. He found that, all right, bulk data usage, what bulk data was scheduled for business hours. Bulk data is all these backups and all this stuff. So it was scheduled for business hours, and because of which both of them had to fight again, just like we saw earlier. And so using bandwidth reports, he got reports about when was the non-peak usage, and he shifted or rescheduled the bulk data for that time period and assigned the QoS priority for void traffic. And then he studied the data. Based on that, his void traffic was acting downward. So studying the effect of network changes you're using, you do like QoS implementation or stuff like that, using your reports, and then see how your network is performing. So coming to this frequently asked question, SNMP, NetFlow, or packet sniffing. So SNMP is just a basic method where you get information on traffic usage from any SNMP capable device. You get to see what was the traffic volume, speed, and utilization. But not any further information like port, or protocol, IP address, nothing can be seen. So overhead-wise, yeah, it's very negligible, nothing much, no strain on the resources. And then there is NetFlow, which is the most optimal method. So that's one. NetFlow, we saw it answers the questions on who, what, when, and where of your IP traffic. So very detailed information with less or rather ignorable overhead on your network devices as well as your resources. And the other option is packet sniffing. So packet sniffing is very advanced, very detailed, as well as very expensive. So you can get a lot of information per packet for each packet, what has happened. And basically it requires a port span or a port mirroring and very lots of resources because the amount of data involved would be huge. So that's what packet sniffing is. And which one would you use is, I would say it would be a combination of one or the other depending upon what type of network you have. When you do not have NetFlow available or you do not need a very detailed visibility like going into your servers or maybe your usage servers, then use SNF to find out what is the bandwidth usage by your system or your switches or the systems in your data center or in your server farm. So, but you can also use it when you need accurate reports. That is because you can compare your SNMP-based bandwidth statistics with NetFlow-based statistics to find out, all right, everything is to make sure that NetFlow report is accurate or your SNMP report is accurate. So at that point of time, use SNMP. Now, otherwise, NetFlow is, how do you use it? Is implement it throughout your network on all the supported devices, whether you need reports or not. Because NetFlow does not take a lot of space, it's very minimal overhead, and when you do a continuous monitoring, whenever a problem occurs, even before the packets have been lost or the problem is finished, you can actually get your reports from NetFlow. So use cases, we saw a lot of them today. So NetFlow is quite important. Implement it throughout at all times and do a proactive monitoring using NetFlow. Now, when do we come to packet sniffing? So packet sniffing is resource intensive, data intensive, huge storage requirements, especially a 100 gig link or even a 1 gig link would have huge storage requirements when you use packet sniffing. And you cannot switch on packet sniffing at all times, have packet sniffing capture data at all times. So use it in high priority environments like data centers or server farms, and or keep it in the standby mode. If you are a huge enterprise, keep it in the standby mode and use it when your problem has been detected by NetFlow and you need a packet level analysis. So that is when you need packet sniffing, because always remember packet sniffing and analysis which can handle huge amount of data or handle high speed are quite expensive. So confusion is, of course, business. It's a business requisite to have network uptime. So create a high-performance network by proactive monitoring using NetFlow data, which is actually non-intrusive, very less overhead, and you can keep a tab on your complete network usage. And cost savings is high because you have less downtime, you have taken informed decisions to hold back on your bandwidth upgrade or WAN optimization, your network is secure. And for small enterprises, packet sniffing is not an option because it's of its expense, and things free stuff like Wireshark or something like that takes quite a lot of time. So use SLNP and NetFlow, and once you have found out, all right, fine, this is where the problem is from, then maybe you can get some free tools, take your time and do a packet analysis. Whereas for medium and large enterprises, always go with NetFlow monitoring or packet sniffing, and use packet sniffing as and when necessary or at important interfaces. So all these screenshots which you saw here were taken from ManageEngine NetFlow Analyzer, which is actually a solution for monitoring, analysis, and forensics. So you get reports for, suppose all the flow formats which we saw like SFlow, JFlow, IPFix, NetFlow, AppFlow, etc. And almost most of Cisco's monitoring technologies are supported. NetFlow, MediaNet, CBQs, that is for quality of service reporting, NBAR, IPSLA, Cisco WAT, all the monitoring technologies are supported. And then it has additional features like anomaly detection, behavior anomaly detection, enhanced Cisco ASA reports, reports on autonomous system information, and then there was, we also have a distributed architecture-based enterprise edition available, which can be used for monitoring more than 250 distributed interfaces or distributed locations or even high traffic environments. And future enhancements on NetFlow Analyzer includes more flexible network fields and Cisco's performance-based routing and Cisco smart logging and telemetry, NBAR to QoS fields within NetFlow. All these are the enhancements we are planning in ManageEngine. So to take on these question and answers, we have had quite a number of questions during the webinar, so questions are still popping in. So if anybody was not asked a question yet, or those who still have more questions, feel free to type in your questions. Flow. All right, that's a good one because NetFlow, like we said, is based on the flows on the key fields, whereas SFlow is based on sampling. So what does it do is, whenever you have packets passing through your network or through your interfaces, a sample of NetFlow packet is collected, and one of it and is sent to the flow analyzer. And let's say the flow sampling is, let's say you have to set a sampling rate of, let's say 256. That is an example sampling rate you set. What it means is 1 in 256 packet is taken out and sent for analysis. And based on the information in that one packet, the traffic information for the rest of the 255 packets are constructed. So this way, you get a complete picture of the traffic analysis, traffic pattern. The only limitation is SFlow might not be or is not as accurate as NetFlow is because of the sampling method it works. And but you can, the max difference of should be not more than 5 to 10% from NetFlow-based reports. And yeah, well, another question we have had is regarding the security analytics module in NetFlow Analyzer for ManageEngine. Is that based on the NetFlow packet analysis? Yes, our module, the flow-based security analytics module, is based on NetFlow packet analysis. So how it works is NetFlow packets contains a lot of information, like how much was the header size, how much was the packet size, how much volume of data was there, what was the payload for the original packet. Not the content of your payload, but what was the volume of the payload. And we have our signatures, or we have some information stored within our product. It says that, all right, TCP packets are expected to have at least so much bytes of data, or UDP packets are supposed to have so much bytes of data. Or maybe we can say that we don't expect one system to send out send out a scan on so many number of ports or to so many number of IP addresses. There are so many things that can possibly be an anomaly for your network, but will not be detected by the flow and by your IDS or IPS. So using that NetFlow data information, the security analytics module of NetFlow Analyzer will give you reports about anomalies, network anomalies as a way. and help you with finding out network anomalies going out of your network as well as those coming beyond your ITS and IPS. A third layer of security is what I would call it. So something else was why does ManageEngine NetFlow Analyzer not capture multicast traffic? For multicast traffic reporting, you actually need flexible NetFlow with the relevant fields, relevant key fields or records or match statements and collect statements used. So if you have used that, NetFlow Analyzer or the ManageEngine will report on multicast traffic, telling you how much of the traffic was multicast, what sort of application was it, and what is the source IP address, source of that multicast traffic. So for those who have not been able to get it working, just drop us an email and our tech team, Technical Assistance Center, can help you with the implementation of multicast traffic. And so we are receiving a lot of questions. So something else is, we are receiving quite a number of questions. So another question that has been asked is, if a new application or a custom application has been implemented, can that be found using NetFlow, or can that be can it be monitored with NetFlow custom application deployment? Yes, that can be done. NetFlow Analyzer actually has around 1,500 applications mapped into its database using based on the IANA positions or IANA report. So for those who have a custom application, NetFlow Analyzer provides an option to add that port and protocol mapping to that application name. You can even tie it up with an IP address or IP network or range. So maybe this application coming from this IP address should be called XYZ, and the same application coming from a different IP network should be called ABC. So like that, you can deploy your own application and then add your own application and use that. Using that, you can monitor. Using NetFlow Analyzer, you can monitor that application and get specific reports. So we still have questions coming in. Some of these questions we have not been able to answer. What we'll do is we'll take up those questions and send the answers directly to you by email, and we'll also have the presentation as well as the recording of the webinar available for you online. We'll send you the presentation also directly so that you can download it. And any questions on NetFlow Analyzer, you can also email our team, NetFlow Analyzer support@manageengine.com, who can help you with your technical questions. If you need any support for implementing flexible NetFlow or migrating from NetFlow v5 to version 9, you can contact us. We'll help you. And for sales-related question on NetFlow Analyzer, you can email us or directly the sales team. And don't forget to check out our blogs and forums. So thank you everybody for joining, and we'll keep you posted on the next webinar, which is mostly about how you can create a better network, how we can manage your network bandwidth, which will help you in implementing your QoS policies, and we'll keep you posted on that very soon. Thank you so much.